Dear all, so today we are going to discuss the numerical expression for power delivered to the load. So in the magneto-hydrodynamics power generator, so how much power is being delivered to the external load, or we can say power generation throughout the process. So a lump sum expression or lump sum idea you would have with the help of some numerical analysis. So it's a idealized or generalized formula, idealized and generalized expression. So not actual calculation, because so many assumptions are made before going to start analysis. Here we can see whenever a charged particle is moving in a magnetic field with a velocity v, experience some force on it, as so many electromagnetic field laws says. So if a charge q is with a velocity v is moving in a magnetic field, so it experiences the force F, it can be written as q times v into v. Similarly, if the electric field is also there, so total or net force is experienced by the charge is written as like this. And this equation we can see the velocity we use in equation v is vector sum of gas velocity v and the particle drift velocity u. Here up to expression 1 or up to equation 1 we have used the gas velocity, and the stream of gas we have just neglected, we have just ignored the drift velocity. Now about the drift velocity already we have discussed when the cesium and potassium elements after receiving some high energy source, receiving energy, they get ionized, and they split into ions and electrons. So ions are attracted towards cathode and electrons are attracted towards anode. So this is termed as drift velocity. Here we have presumed that the drift velocity is u. Thus force is given, so including incorporating drift velocity also. So net force experienced by the gas stream, it can be written like this. So here you can see the equation number 2 summarized here. So now we can say, now we segregate two expression in two different terms. So we are just putting only kept aside the drift components only. The force due to drift velocity just keeping aside and merging these components on these merged component can be written as E dash q times of E dash, and E dash is nothing else is the expression from this to this, a force due to electric field and force due to magnetic field with the velocity with the charge q is with the velocity charge flowing with the velocity v. So this is equation number 3 is showing that. What about E dash? We have used in equation number 2, okay, and modified form equation number 2 here. So you can see the line diagram also. Here x, y, z are the three mutually perpendicular axes along x directions. So you can see the velocity of gas. Along y direction is the magnetic flux, magnetic field. Along z direction is the drift velocity, you can see. So electric field also. Okay. So likewise you can judge here from figure. As I mentioned, in x direction there is a motion of gas, velocity of x. B in y direction, the magnetic field in y direction, and the force on the particle in z direction. Okay, so this one is the force experienced by the charge. If the distance between the plate is d and the electric intensity in between the plates, so I am just going to here. These two plates, distance between these two plates is d. So So charge between these plates, how we can see this? So depending upon the potential difference, by using the potential difference V by D. So this is the distance between the particle. The electric intensity, we can say electric intensity V by D Ez it is noted as Ez. So total electric field, is can be written as Ez maybe like this here. So in place of Ez, E dash Ez, E dash is the VB plus VBD minus this Ez. The electromagnetic fields Ez and B, electromagnetic fields. Now the field is becomes electromagnetic fields. Electromagnetic fields, Ez is the electrical component, V is the magnetic component. Acting on the moving gas or moving charge produce the same force on the ions as the electromagnetic fields Z dash and B produce on gas with zero average velocity. This is the concept of electricity force. The term VVD gives the internal EMF in open circuit. Okay, VVD is always produced as internal EMF. Internal EMF is nothing else. A circuit having its own resistance, and in order to encounter the resistance on some charges or potential difference required to flow charge inside it. So this resistance of the circuit own circuit is termed as internal resistance, and the EMF induced at this circuit is called internal EMF. So internal EMF nothing due to the magnetic field, velocity of charge, and d is the distance between the electrostatic plates, electrodes you can say. Okay, so this is the EMF produced by this VVD, you can see here, due to Faraday's laws. So if R naught is the internal resistance, RL is the external load resistance respectively, then the current I through the circuit current can be written as V is the net potential difference, okay, net potential external load upon total resistance of the circuit, internal resistance as well as external load resistance. So this is external current I through the circuit current. So the power output can be written as V equal to V naught times I. So here we can it can be I square R can be written as like this. So in place of I we can put V naught upon R out like this. So when the question arises, the maximum power delivered to the resistance, external load resistance. So it happens only when the RL equal to R naught. Okay, RL equal to R naught. Both circuits have the same type of resistance force. So in that case, we will have that. So by putting R equal to R naught, this expression becomes 4R square like this, VVD square, and V naught. In place of V naught, we will look VVD. Here we will the VV square, and D square like this, D square. So R naught upon D, that becomes sigma. Sigma is the conductivity of gas. Is a R means ohm, inverse of ohm is mho, conductivity, unit of conductivity, and per meter. So 1 upon D per meter like this only. So D square, 1D is cancelled out, D will left over here. Oh sorry, D will left over here. Okay, so D will left over here. Sometimes if we are talking about the total output, maximum power output, okay, so in that case we have to include cross-sectional area of plate also, electrode plate also. So we have incorporated a electrode surface area also A. So the equation 7 shows that the maximum power output given by the MHD power plant. And similarly the maximum current also. So maximum current in case of maximum power output is V naught upon V, already we have told you, this becomes 2R VVD is just maximum current output is load per here. So this way we can calculate easily now the power generated by the MHD power plant is done. So few various things, main things is to be noted here. That the main thing is, first of all, this is VVD. VVD is for internal EMF. This keep in mind. whenever numerical expression will come and numerical will come, so just they will ask a calculation